Let me start by saying a few words about midterm. Because I received a few requests for postponing the midterm, and having realized that we all have our priorities, I am of course going to reschedule the midterm, and it will be on the class time. So the midterm will be on Tuesday of the next week during the class time. Why? Because next Tuesday follows Monday. So it's like Tuesday is Monday. So the midterm, therefore, will be on Tuesday next week during the class time.
Professor.
Thank you,
Yes.
Professor.
So does that mean like if we emailed you separately about a different day, does that also get pushed to Tuesday?
That changes everything. So because I always allow to write the midterm if a person cannot do it on the exam date, a day before or a day after. So I will say a few words about that as well, but please before that I have to fix the new date. So midterm exam is on Tuesday, which is
the 29th, right?
yes, that looks like that.
Professor?
Yes.
Fine, Professor.
Would you make any exceptions, like, to take it on Sunday, like you said before? Because I just booked flights, and I won't be in New York, or, like, I won't be free on Tuesday.
Okay, then you can do it either on Monday or on Wednesday, because that is my policy that I always allow students to do it a day before or a day after, given they have a plausible reason they cannot do it on the exam day.
Oh, because, like, I thought it was Sunday this whole time. That's why I, like, scheduled everything around that.
Okay, just email me about that and we can fix it date.
Okay, thank you.
Professor, can all of us do on Wednesday? Is it possible?
I think Wednesday works better for everyone.
It will be highly appreciated.
Okay, then we will have to but the thing is on Tuesday, I will not be explaining or doing any kind of review because we have to move on also, right? So
wait, Professor, I'm confused. Why don't we do it when we have scheduled class time? Why does it have to be when we don't have scheduled class time?
No, Tuesday follows a Monday schedule. It's on the calendar.
Tuesday.
Oh, okay. Sorry, I came in late.
yeah, but I already said it. So guys,
Yeah, Wednesday is better for all of us.
okay, then the thing is, we will start chapter 4, like maybe on Tuesday, and the exam will be on Wednesday,
You
right?
don't have to review on Tuesday, Professor. It's fine. If you leave a second on Wednesday, we'll keep on.
Okay, then that's
What schedule is on Wednesday?
The 30th.
Monday.
Regular.
It'll be Wednesday.
Oh, okay. It's just Tuesdays and Mondays schedule, and Wednesday's regular.
Yeah.
Guys, okay, no,
Oh,
don't.
all right.
There's no class on Monday.
So you are even confusing me. So please let us
I'm
fix a
sorry.
date. So let's do it then on Wednesday.
The 30th.
Wednesday, September 30. During the class time.
Oh, during the class time? Okay.
Yeah, which is 2:30, right?
Yes. To 3:30.
Oh, sorry.
45.
No, it is 2:30, right?
I think it's 2:45.
2:30.
No, it is 2:30.
2:30.
Yeah,
3:45, it's fine.
3:45.
There we go, yeah.
So now I think we are all set.
Yes.
That's the exam date.
Professor,
Yes.
real quick, if we take the test on Wednesday, when will we have a review?
We're not gonna have a review, he said.
We have review right now. So
Yeah.
we will we will solve. I already solved problems from chapter 2. I did solve a lot of problems from chapter 2. And you can take a look at the recording. I will solve problems from chapter 3 today, and I may solve some problems in the first part of next Wednesday's class of this week, right? And then I have to start chapter 4. Do you see what I mean? To stay on the program. And the Wednesday a week after, you will have on September 30th during the class time, you will write the midterm exam. Am I clear?
Yes.
Yeah, this works.
Very nice. So let me also, okay, guys, I know that you already, some of you already contacted me to write the exam at another date, but please email me again. And also, if you emailed me about your, if you emailed me your accommodation cards, please email me again, because I have received a lot of emails about this and I don't want to mix stuff. So I want you to get the proper timing and everything to be smooth. So email me again, but the date for the midterm is Wednesday, September 30, during the class time, which is 2:30 p.m. Until 3:45 p.m. And again, if you guys have any questions, please let me know, reach out via email or during the office hours, or you can also,
Professor,
yes.
are you aware of the possibility of opening the exam the whole day?
No, that's impossible. I'm not going to do it because I think the exam is to be written in a limited amount of time. It will be based on homeworks, very similar to the homeworks, but will have to be done in a limited amount of time, which is 1 hour and 15 minutes. As I said, if you guys do the homeworks, you'll be fine, and I will post the details about this midterm maybe today or like in 1 or 2 days, 2-3 days.
Okay, sounds good.
Professor, I just had a quick question. So if we, after the due date of the homework, you'll still be able to access them, right? To practice and everything?
Yes, the thing is I am always extending. So even if you don't, I mean, even now you should be able to see, even if you make mistakes, I think it gives you hints or something like that.
Yeah, no, I was asking if after the due date, we will still be able to access them, right? Because the exam is after the due date of homework.
Yeah, you will be able to access it, but you will not be able to access the exam before the exam time, right? Okay, guys, so if that's clear, let me start doing chapter 3 problems. So this will serve as a review for the midterm, right? Next Wednesday, I will also solve some problems from this chapter 2 and 3, and that will also serve as a review for the midterm, and then I will very likely start explaining chapter 4, given I have enough time. And on Tuesday of next week, which follows Monday, that's why we have class on Tuesday, I will explain chapter 4 again. And then on Wednesday, you will write the midterm. The office hours will not be on Monday, but instead will be on Tuesday, because Tuesday follows Monday. Hopefully I'm clear. Again, if you have questions, feel free to ask.
Professor, I have a question.
Mm-hmm.
So I know we're doing review right now, but I was wondering, are we going to be able to get a practice midterm or no?
No, because homeworks serve as your practice.
Okay.
All right, let's start.
Yes, we start already. Let me copy. Do you guys see my blue screen?
Yes.
Yes. Cool. Okay, guys. For this problem, we will need to use a table. A standard normal distribution table. So we will use central limit theorem to answer the following questions. We need to find the probabilities that y bar is less than 101. So probability, so this is A, that y bar is less than 101. Y bar has a normal distribution. We need to standardize y bar to be able to use the table that we have, right? To be able to use standard normal table. We have to standardize y bar. If you guys remember, before I said, how do we standardize a random variable? We subtract from the random variable its mean, which is mu of y bar, and divide it by the standard deviation of y bar. This will be standardized y bar, which we denote by z. But mu of y bar, we showed before, is the same as mu of y, and sigma of y bar, we showed this sigma of y divided by square root of n. If anything is not clear, please let me know. So instead of y bar, you have to have z, right? So you have to transform this whole thing, right? So how do you do that? You do this as follows. This will be probability that y bar minus mu of y bar divided by sigma of y bar, which we already know is capital C, is less than, and you have to do the same transformation to this 101 as well. 101 minus mu of y bar divided by sigma of y bar, right? This equals probability that this is C, right, is less than 101 minus mu of y bar is the same as mu of y, and the sigma of y bar is sigma of y divided by square root of n, right? Do we have this information? This is the probability that Z is less than 101 minus mu of y is 100 according to this problem. And then you divide it by sigma of y bar, which is 43, divided by square root of n, and in this case is 100. Okay, so then this equals probabilities that Z is less than, if you do this calculation, this is what you have. Guys, is anything unclear up until now?
Yeah, could you scroll up to the question real quick? I want to ask you something.
Sure, sure.
All the way up to the actual question. So it's given that sigma squared is 43. So is that the same as sigma y? Even though
No, this is sigma squared. That's the variance. Sigma of y is standard deviation, which is square root of 43. So did I miss that?
Oh, okay.
So I missed it completely. So you're right. So I have to have square root of 43, right?
Yeah, I was confused because I was, yeah.
Thank you very much. So everything is fine. So this is sigma of y. That's not sigma squared of y. Sigma squared of y is 43. Sigma of y will be square root of 43.
So you're given the variance instead of the sigma?
Yeah, so this is variance.
Right.
This is
All
the
right.
variance. This is not the standard deviation. Standard deviation is square root of the variance, which is 43.
So if
Square root of 43.
so standard deviation will be denoted as just sigma without the square.
Yeah, that's what I have here.
I got it.
And also, I got another question.
Yes.
So from looking at the question, how did you know you have to find C?
Okay, so as I said, you have to find the probability y bar is less than 1 or 1, right? But y bar, you can only do this kind of problems if your random variable has a standard normal distribution. Why? Because the table that we have is about standard normal distribution table. Is standard normal distribution table. Are you guys with me?
Yeah.
Now I am sharing you a different screen. Table. This table is about z, it's not about y or y bar. Z is a standard normal variable, not a variable that is normally distributed. So you have to transform your normally distributed variable into standard normal random variable to be able to use this table. Am I clear?
Yep.
And that's why I transformed it. Because I know that y bar is distributed as normal with the mean mu of y, variance 43. That's not enough. So I mean, I have to transform this normal random variable y bar into a standard normal variable z. Z is transformed or standardized y bar. Okay, and I gave you the details here. And when you are at this stage, then you are able to go to the table and see the probability. So this number will be your small z, right? Which in that table is decomposed into two parts. 1.5 in this case and 2. That's a weird table, but that's how it is decomposed there. Are you guys with me?
Do you round it to 1.53 or you leave it as 1.52?
Very nice. Should be 1.53 because, you know, if you round it, that's what you get. You get 1.53, not 52, right?
Professor, I have a question. So during the exam for questions like these, are we gonna get a room for error, like a couple of decimals?
No, that's why you will. I will say a few words about that as well. So you will have to use Excel if you want to get the exact correct answer.
Do you know how to do this with Excel? Because it says like array.
I will show you guys. I will show you right now. But let me give me a few moments. Let me finish it, and I will show you that in Excel as well. Okay. First, let's do it by using table. So let's go to the table, and let's see 1.5 and 3. Guys, do you see do you see the table?
Yeah.
Yes, we do.
So 1.5, so we are in this row. Okay, sorry. 1.5 is here. And then 3 in these columns. Okay, let me go down. That's the number, right? If you round it to 3. So 0.937. This will be, but this will be an approximation, 0.93 and 7. Let us do this in Excel right now. Let me share my screen with you guys. So if you guys have any questions, just let me know, right? Guys, do you see my Excel screen?
Yes.
Yeah.
Yes. Could you go back on the formula for a second, Professor?
Yeah, so you saw what I did, right?
Yes.
But so the formula will be here. Now I will explain it. So guys, as you see, this is a little off. Do you see my blue screen now? Because I'm not sure, because this Zoom confuses stuff. So the answer that we have from the table is 0.937. Okay, and in Excel we have 0.936, and it goes on. For the exam questions, you have to do this in Excel, otherwise you will probably have the issues with rounding, because the table is not exact. The table rounds stuff. Do you see what I mean? For example, 1.525 means you cannot do anything. If you cannot find probability unless you round it to the second decimal. In this case, we rounded and we had 1.53, but that's not exact, right? So if you want to do this exactly, you have to use Excel or some other software like R or
Professor, don't the Pearson homeworks and everything already use the actual graphs for like references answers?
The Pearson is based on Excel, and because Pearson wants from you guys the exact numbers, the exact answers. Sometimes they are asking you like 4 decimals, 3 decimals. The tables are not that precise.
Because I've been using the tables and I've been getting the answers right. So
Yeah, I've been using the tables too, and I've been
it
getting
tells
the
you
answers.
in the. Sorry.
Most of the time you will, unless it asks you to enter the answer like until up to like 5th decimal precision or something like that.
For
Then
the homework, they ask for the 6.
so guys, okay, so now we are wasting. I'm sorry, but let's. So I already said, right? So if you want to get the exact answers, you are better off if you use Excel.
Professor, the 0, 1, 1, that's because it's normal distribution?
No, because it is standard normal. I standardized it, right?
Right.
But you could like, if you wanted it like without like what I did, if you wanted still to get the answer, that's the function, right? That's normal, that's the function. And you provide x. My x is what? 1.50, you see, right? Where is it? My x is 1.52 and 5, right? That x is small x, you see, right? That is not a big x. It is like z in our case. And I wrote 1.525. In table, I had this, right? Okay, and comma, and then enter mean. Mean of what? Mean of your z, but z is standardized, so the mean is what? 0. What is standard deviation of standardized y bar? Standard deviation is 1 because standard normal random variable has a standard deviation of 1. And then, are you asking for a cumulative distribution, or are you asking for a probability mass function? We are asking for a cumulative probability distribution function. That's why either you write true, or you can also write 1. Both serve the same purpose, and you get the number, the answer. Why are we looking for the cumulative probability density? Because the distribution function, because as you see, guys, this table, as you see here, this area is cumulative probability. It's not this is cumulative probability, right? Because it gives you the probability that capital Z, which is the standard normal Z, is less or equal Z. Less or equal, when you have less or equal, that means you have a cumulative probability distribution. Guys, am I clear?
Yes.
Yeah.
Then let me solve another question. Now let's do this probability, right? B. We're now looking for the probability that y bar is greater than 101 less than 103. What is the next step? The next step is to standardize this y bar. Okay, let's do it. This will be probability that in a standardized y bar, this is y bar minus sigma of y bar divided, minus mu of y bar divided by sigma of y bar. We call this capital Z. Eta or equal or theta does not matter, is the same for the continuous random variable. 101 minus the mean of phi bar, but mean of phi is mean of phi. Mean of phi bar is mean of phi. So 101 minus mu of phi was what? Mu of phi is 100. Yeah, because it's the same problem. So guys, please help me. And divide by sigma of phi bar, but that is sigma of phi, which is square root of 43, divided by square root of n, which is 100, right?
64.
And, oh, 64. Sorry. Okay. So they changed it. Is it the same? 43 is the same, right? Okay. 101 minus 100. So 103, right? Minus 100. Divide by 43 here and then 64.
101 minus 64.
What?
This is the mu y 100.
Mu of phi is the same, 100. The only change that we have here is that this is any 64 in this case. And if you do those calculations, you are getting this is 122. Guys, double check these calculations because sometimes I may have some typos, but it's okay as long as you understand the idea, then you are fine. But this is, what is this, guys? That's this is standard normal density, right? Here we have 3.66. So, and then let's say here we have 1.22. So this probability is what? The area between these 2 points. Guys, are you with me? And but that is what? That's the, I'm not sure how we are doing in terms of time. So that's the whole area minus, let me take a different color, minus the area below this. Okay, so then you can write this probability as follows. Probability z is less than 3.66 minus probability z is less than 1.22. Okay, and then now you are ready to go to the table or maybe use Excel. Guys, are you with me? Of course, you can use table, you can use Excel, both are fine. But which one do you want to use, guys?
Excel for that.
Excel.
Okay, then I just do this. This will be 3.66, right? And that will be the answer. Here I will copy the, sorry, what did I do? I will copy this, paste it here. See how I do it, and then I will just change it to 1.22. Okay, and then that's it, and then equals what? This minus that. That's it. Maybe I want, guys, is this better? So do you see what I did? That's the answer, right? that will be the exact answer. In table, you can do the table, do this problem using table, but your answer might be a little off. Definitely will be off by like, it will be correct up to some decimals, 2, 3, but then it will be off. Are you guys with me?
Yep.
Okay, then 0.11, let me do it like 0. This will be 0.11, but okay. And the last one is the probability that y bar is greater than 98. Probability that y bar is greater than 98. Okay, then first thing first. You have to have z here. But you have to have z here, that's right. But if you have z here, then you have to transform this number 2, right? Okay, and that's probability that z is greater than minus 3.92. Can you get this probability from the table? Do you see the table?
Yes.
Yeah.
Can you get that probability from this table?
No.
Why?
Can we just 1 minus that?
And said 2.9.
That's exactly right, 1 minus the, but why cannot you get the probability? Why cannot directly take the probability from this table?
Oh, the number is too big, I think.
It's basically 0.
It's more than 2.9, right?
I see you are very smart, but the thing is, so
It's really
what is,
close to 0.
then, okay, guys. This table gives you probabilities that z is less than something.
You have to do 1 minus the probability.
You have to do 1 minus, right? So, and then you will be fine. So this will be, this is the same as 1 minus probability that z is less than minus 3.92, right? Do you guys agree with me?
Yes.
Yeah.
Yeah.
And this is basically 0, as you said. And this is basically 1. Okay? I explained this before. Because you already know the probability that z is less than minus 2.99 is very close to 0, right? And then this is even less than that. You can do this in Excel as well. And okay, how do you do that? Just let me change numbers. This will be minus 3.99. Okay, what did I? So this is like, this guys means that we have a very, very, very small number. This is like close to 0. This is that times e to the power sound. This is very small. This is very close to 0. This is just writing it. Here you have so many zeros that you just they just shortened it with this.
Professor.
Yeah.
So if you get a question like this on the exam, do we just put 0?
Yeah, sure. That will be 0.
All right. Cool.
But then you have to. So okay. So is it it? No, because in this problem it is 1 minus that, which is, as you see, very close to 1. So the problem, the answer here is 1, right? But Pearson may ask you round your answer up to, let's say, 5th decimal or 4th decimal, and then you enter 1. You are right, but Pearson tells you you are wrong, because maybe Pearson tells you that give me 0.9999 instead of 1. Okay, let me finish this problem and start a different problem. 3.6. Guys, you also realize that I will not have time to do all of the problems, right? But I will do, let me even, this 3.6 is very simple, so let me do, let's say 3.7, then do 3.8, 3.10, 12. Okay. Let me do 3.7 first. So I will upload the solutions of all of these today, guys, but let me postpone 3.6 and 3.7 for a later time, and let me do 3.8, 10, 12, maybe 17 for today's class. And then I will go back to, so I'm not skipping anything, I'm just postponing some. Let's do 3.8. Do you see, what do you see when you see my screen?
Textbook?
Very good. So now Zoom works well. Sometimes it mixes up stuff. I don't know why. But now we are fine. Okay. So what do we have here? We have N, here is 1000. Looks like 1000. Sample mean is, which we denote by Y bar, 1, 1, 1, and 0. Sample standard deviation, sigma of Y is 1, 2, and 3. And we are asked to construct 95% confidence interval for this. Okay, 95% confidence interval is constructed as follows. That's
Professor, I have a question.
Sure.
For the standard deviation, shouldn't it be standard deviation of Y bar, not standard deviation of Y?
That's a very good question. It's a standard deviation of Y, and I will explain why.
Okay.
Professor.
Mm-hmm.
So the test statistics formula is, I think it's Y bar minus, I think, mu over standard deviation. But for some examples, you divide standard deviation in the denominator by n. And I just wanted to know, how do you know when to divide standard deviation by n?
Depends. Up until now, I have always been dividing by n.
So I guess if you're given an n, you just divide that with the standard deviation. So
The thing is, if you want to calculate probability, let's say this is extra, right? Not related to what is, not related to this particular question, but okay. If you want to calculate probability that Y bar is less than, say, 2.10, right? So then you have to standardize Y bar. And how do you standardize Y bar? Y bar minus mu of Y bar and divide by sigma of Y bar, right? But we showed that mu of Y bar is the same as mu of Y. That's why I write this here. But we showed that sigma of Y bar is sigma of Y divided by square root of n. It depends what do you have here.
All right, okay. So I guess if n wasn't given in the problem, you would be solving for just y.
If n was not given for the in this kind of problems, then you would not be able to solve the problem.
Okay. All right, got it. Thanks.
Wait, so y bar means sample, right?
Y bar is sample mean.
Of y.
Oh, okay, okay. Yeah, that makes sense.
Of
Okay.
Y, yes, of Y, yes. So now we are asked to calculate this. We know that this Z critical at 5% significance level is 1.96, right? This is 1.96. Y bar is 1110. Here is 1110 plus. And then what is this? Times. Sigma of y bar is what? Sigma of y divided, sorry, this is a mistake. Should be sigma of y divided by square root of n. Sigma of y is 123 divided by square root of n 1000. And this times 123 divided by this. And then this will give you two numbers. Okay, that's it. Now let's do 3.10.
Professor, I think you kind of made a mistake on like when you were writing it.
What did I do?
So you wrote 1,110 plus 196. Isn't that supposed to be a minus and the other one's supposed to be plus?
Yes, very good, guys. So I'm so sorry about that.
Extra credit.
You're right. So minus and plus. Am I clear now?
Oh, and what are you supposed to do with the confidence interval? Okay, never mind. I got it.
That means 5% significance level, guys.
Yeah, I got it. Thank you.
95% confidence interval is 1 minus 0.095. This is 0.05. This is 5% significance level.
Professor,
yeah.
If we do a small mistake in rounding, for example, like if we do like 155 instead of doing 1.56, and the Pearson obviously is going to tell us is wrong, would you give us a credit for the question or no?
So guys, so you have to be very careful, right? So if I do something for one student, then I have to do the same thing for others too, right? So to be fair.
I think this is wasting time.
I know.
You've answered this question so many times, it's like ridiculous.
Okay, that's fine. Maybe people join later. That's okay, completely fine. But guys, let me say this again. So Pearson is exact. So okay.
About the 3.8, I'm so sorry, like the one you just did. You have like numbers.
Are different numbers?
You have to. So 1,110, you have to plus 7.62, and you have to minus it, right?
Where is 7.62? Where do you see it?
I mean, look, you have like the. Do you see you put like minus 7.62 and then plus 7.62?
This here, right? These are numbers.
Yeah, so you have to 1,110. You have to minus it and then plus it, no? And the
no, guys. Okay, so this thing, I will double check it, but this thing should be minus 7.62.
I mean, for homework, it was like you have to minus it. No, it's supposed to be 1,102.37 and 1,117.
Okay, guys, so now you are like helping me, but let me make it clear.
Yes, please.
When you do this,
yes,
what do you get?
I got for minus, I got 1,102.36.
Let me double check it.
Yes.
Equals 1110 minus 1.96.
Yeah, I got
times, and then we have 1, 2, 3, right? Divided by square root of
1,000.
Yeah.
I am missing one.
Yes, I got this.
Okay, so then probably that's it.
Yes, and the second one is going to be 1,170.
Yeah, so that's a mistake. So I just put different numbers from, okay, that's incorrect. So that's what you should be getting. So whatever you do here will be one of your points. So looks like it is 7.62 was 111. I just copied a different thing, so that's what you have, right?
So, Professor, why is it this standard deviation and not the sample standard deviation?
Can you please repeat? Because I don't
And the
think I.
questioner gives you the sample standard deviation, but you write it as the standard deviation, and you said you'd tell me why.
I said I told you why, and I will tell you right now. So whoever noted this, that no, you're right. So the answer will be 1110 to 38. 1110 11. What was it? 110 to 38. 110 to 38. And whatever is here, guys, and then this will be
7.62.
I will just do plus and 1117.62. 1117.62. Am I clear now? Let me now answer to the persons to this question. Why is 1, 2, 3 sample standard deviation standard deviation of y and not standard deviation of y bar? Do you take a sample of y bars?
No.
And then why do you ask me that question? You took sample of y's, right? And that's the sample standard deviation. Did I answer your question?
Yeah.
Okay. Now let's solve 3.10. So let me go back and answer to that person's question who asked about, like, do we have to be exact? And you have to be exact because if you, okay, I understand. So let's say your answer is 1.56, and let's say the true answer is 1.55678. And let's say Pearson tells you round your answer up to 4 decimal. So then looks like this is the answer Pearson has, right? So please try to be exact, and Excel allows you to be exact. But again, so after every exam, I have exam review. And if I see that you made careless mistakes, then I will adjust your scores. But I have to first be sure that you made a careless mistake. Right, so I'm here to help you guys instead of like harm you. So I will try my best to help you. But if Pearson tells you to provide the answer up to, let's say, 4 decimals, you have to do it. Am I clear?
Yes.
Okay. Let's then solve another problem. So this is an interesting question that we will solve now. So there is a standardized test that is given to samples, to groups of students. But let's start first from part A. Sorry. Let's, what is this? It's one part. Something. Okay. I'm not sure what's going on, but that's okay. So we have sample of 100. I really don't know what's going on. Let me close this, guys, and reopen it. N is 100, but this is N of New Jersey. Then Y bar in New Jersey schools is 58, and sample standard deviation S of Y New Jersey is 8. They're asking let me do A here. The authors plan to administer the test to all third grade students in New Jersey. Construct 95% confidence interval, okay? Then that will be confidence interval for what? Mu of phi. And that we know is, as I said before in the previous problem, that will be Y bar 58 minus 1.96 times 8 over square root of 100 and 58 plus 1.96 times 8 over square root of 100. That's the 95% confidence interval. If I have it here, let's I mean, double check the numbers, guys, so please double check it, but hopefully these are right. Minus 5, minus 56, 43, 2, and 59, 56, and 8. That's it. Now let's do B. Now we have a different group of students in a different state. So they gave this test to students in Iowa, and they have different measures. So now N in Iowa, sorry, not V, but, is 200. Y bar in Iowa is, what is it, 62. And the sample standard deviation of, how did I, sample standard deviation of S of phi, but in Iowa is 11. So then suppose the same test is given to 200 randomly selected third graders from Iowa, producing a sample average of 62 points and a sample standard deviation of 11 points. Now they're asking to construct 90% confidence interval for the difference in mean scores. What is the difference in mean in this case? The difference in true means is mu of y in New Jersey, sorry, the mean is in Iowa higher, the sample means I will write mu of y in Iowa minus a mean of y in New Jersey. Y is a test score, right? Random variable. And this is the denotes true difference in the means. Am I clear? And you want to construct confidence interval on that based on what? Guys, can you help me? Based on what? Y bar in Iowa minus Y bar in New Jersey. Okay. So plus and minus what? Critical value at 9%. Critical value at 90%. So then 10% significance level. Right? Am I clear? This is the critical value. %, significance level. Okay. This is from the table, so but I already said there are 3 conventional levels of confidence and therefore significance. So this is one of them. This is 10%. At 10%, and then you need what? Times sigma of what? Y bar Iowa minus Y bar New Jersey. So do we know this Y bar in Iowa? We know, right?
Yes.
Do we know Y bar in New Jersey? We know, right? But do we know sigma of? Okay, so this is it will be great if I write just as a subscript, right? So then you will not get confused, right? This is sigma of this is subscript Y bar Iowa minus Y bar New Jersey. Do we know this? So that is what? That is. No, we don't. But this is what? Square root of the variance of what? Minus Y bar New Jersey. So then let's first calculate Z variance. This is Jersey minus 2 times covariance between Y bar Iowa and Y bar New Jersey. We assume the 2 samples are independent from each other, so this is therefore 0, and we are left with that. But variance of Y bar Iowa is what?
Wouldn't it be the sample standard deviation squared?
That's very true. That's very true. But even before that, we know that. So, what is variance of Y bar? Do you remember in general? That's variance of Y divided by N, right? And this means that
Isn't it
sigma.
square root N?
No, if you take square root, sigma of Y bar will be sigma of Y divided by square root of N. I think you are mixing this with that. So this is variance of Y in Iowa divided by N in Iowa plus variance of Y in New Jersey divided by N in New Jersey. So, do we know what is variance in Iowa? That is sigma of phi in Iowa squared divided by square root of, divided by N in Iowa plus variance of y New Jersey will be sigma of phi New Jersey squared time divided by N in New Jersey. Do we have this information? Do we know sigma y Iowa?
Yes.
Yes, that's 11. So 11 squared divided by what is N in Iowa? 200. Plus what is sigma in New Jersey? 8 squared, right? Sigma squared, 8 squared. N of New Jersey is 100. So that is something that goes here, right? So eventually you have the following. 62 minus 58 plus and minus 1.64 and 5 times what? The square root of 11 squared over 200 plus 8 squared over 100. This will give you two numbers, right? And these two numbers are minus 5, 82.99 and minus 2, 17.01. Am I clear?
Professor, can you hold up just a little bit?
Even up? Do you want me to go?
That's good. Thank you.
Mm-hmm. Guys, now let's do part C. So am I too fast or is it okay? The pace, is the pace okay?
It's okay.
Okay. Part C. Can you conclude with a high degree of confidence that the population means for Iowa and New Jersey are different? So this is like you are testing the following hypothesis that H null, that there's no difference between the true means, right? I want to test this. If I reject this H null, then there is a difference at some significance level. But they want us to have a very high confidence depending on that, so we will choose the significance level. The alternative will be is this clear? So what is the next step? Can you tell me? Calculate test statistic. This will be what? Sample analog of that will be what? Minus the hypothesized value is what, guys?
0.
0, that's true. Divided by what? Square root of? Square root of sigma y bar Iowa minus y bar New Jersey, but we obtained that before, right? So this will be y bar Iowa is what? 62. Y bar New Jersey 58. Minus then 0. And then divided by whatever is here, sigma. 11 squared over 200 plus 8 squared over 100. And if you do these calculations, Please double check everything, these calculations. I mean, I should have it right, but sometimes I make it.
I think you have to do 58 minus 62.
Sorry, what?
58 minus 62.
Why?
Because Iowa is 58 and New Jersey is 62.
No, Iowa is 62.
Iowa is 62.
Yes.
But it doesn't really matter. It doesn't really matter. You just, do you remember, you always take the absolute value of the test statistic and then compare it to the critical value.
Okay.
But in this case, Iowa, the mean of Iowa is 62. That should be 3.5849. Okay. Double check that, but I mean, that should be, I mean, that's what I have, but can double check it. Hopefully it's right, but you understand the idea, right? So how we do it. And then if you want to check it like at a very high level of significance, let's say you want to have very high level of confidence, let's say, then you do it like this conventional level of confidence, 99%, so that's very high, right? So then, but what is significance level at this? It is 0.01, and then the critical value is what? See, critical, if you remember, is 2.58. And the absolute value of z. So see now you see why it doesn't matter if you have minus or plus. And you have on the other side this, right? This is greater. So do you reject the h null or do you fail to reject the h null? Because the absolute value of the test statistic is greater than the critical value. That is one of, yes.
Can you just go over when we reject and when we don't reject, like what the criteria have to be?
I will, but I think it was the last class when I explained 3 ways to do it. The first was what? Using the critical value. So you have this test statistic, the absolute value, if it is greater than the critical value, it's some alpha, right? Then you reject. The more details are in the previous class recordings, right? Or if p-value is less than alpha, then you reject. Also, if the hypothesized value, if the hypothesized value falls in the confidence interval, you fail to reject.
Thank you.
More details are in the previous class recording, guys. And but let's say we want to calculate the p-value, right? So what is our test statistic? And that will be the last thing I'll do today. It was 3.5849, right?
Yeah.
So what is the p-value for this? We have two-sided test, right? So then what do we have here is the following. So this is 3.58. The opposite is minus 3.58. We have that area and this area, and the sum of these two areas are what? P-value is p-value, right? But these areas are equal, so if you write the p-value will be what? 2 times what? Probability that C, capital Z, is less than minus 3.58. But this is 0, right? So this is 2 times 0 is 0. So if you do this in Excel, let's see what it gives me, that it is like something e to the minus something very close to 0. Right? You don't even see the zeros here, many, but this is essentially 0. And then you compare this p-value to what? 0.01 because that's the significance level I wanted to have, right? Because I wanted to be 99% confident, right, in what I am saying. Am I clear? And we see that p-value 0 is less than 0.01. So we reject H null again. That confirms what I did before when I compared the test statistic to the critical value. That's it. So that's today's class.
Thank you, Professor.
Thank you, guys. I mean, let me repeat.
Thank you, Professor.
You guys are very, very welcome. So let me just repeat. So the midterm exam is, let me go up to repeat for everyone. The midterm exam is on Wednesday, September 30, during the class time 2:30 p.m., 3:45 p.m. The exam will consist of 18 questions, 12 multiple choice, 6 analytical. The exam does not contain questions about proofs and derivations. The exam does not contain empirical questions. Again, this is a new date of the exam. If you realize this is not convenient for you guys, email me with a plausible justification why this is not feasible for you, and we can reschedule either a day before or a day after. Next, please send me your accommodation cards, because I mean, I have received so many emails before I reschedule this class. I don't want to mix stuff. So if you need more time, I have to have your accommodation card so I can give you the proper time. And finally, next Wednesday of this week, I will again solve some problems, but I will very likely start chapter 4. And on Tuesday, which is, we don't have class on Monday next week, we have class on Tuesday next week, because Tuesday follows Monday. On Tuesday, I will explain chapter 4. And then on Wednesday, we will have the midterm exam. That's the policy for this week and the next week. So guys, thank you very much for being here.
I have a quick question.
Sure.
Is the homework, I think this question, is the homework based on like, I mean the exam, is it based on fully analytical homeworks or like the multiple choice homeworks as well?
Exam is based on multiple choice and analytical, because I already said that there will be 12 questions that are multiple choice and 6 questions that are analytical.
Okay, perfect. Thank you.
Professor, can we leave now? It's okay, we leave?
Yeah, so I am done. So I will also leave, guys. If you don't have any questions.
Professor, can we next class like maybe exercise chapter 2?
We will. I have it in mind, guys.
Yeah.
Professor, I wanted to, I was watching last class's lecture and I just had a question I wanted to ask you.
Mm-hmm.
So, in the last class, you did an example and you wrote down this number that I just wanted to know what it meant, basically. So this is towards the end of the class. I think the date was 9/16, if I'm not mistaken.
Okay, let me see. Last week, which day? 9/16?
Last Wednesday, 9/16. I think 9/16. So the homework, the question was, the question with the potassium content. Do you remember that one?
Yeah.
Yeah. So it's part C.
Let me see. Do you see my blue screen?
Yeah, I see it.
Thank you for the class, Professor.
No problem. Where do you have?
Yeah. So part C. Towards the end of the question, we're comparing the numbers 1.341 and 1.645.
Towards the
I'm not
end.
sure where. It might be a little more up.
This one. This one?
Yeah, right here. So I understand that the 1.645 is the level of significance as a z-value, correct?
That's true.
Okay, and I just wanted to know what the 1.34, like, what number is that? Is that the p-value or something?
1.34?
Yeah, 1.341.
That's the test statistic. So this 1.64, that is z critical.
1.34 is z
Test.
critical?
No, z statistic or test statistic. So this is it.
All right, let me just write this down. So I guess you take this number and you look it up in the table. Is that correct?
No. You just calculate it. So see, do you see this?
Oh, okay, yeah, I see it. Okay, got it. Test statistic.
And you compare it to the critical value at some significance level. This is at 10%.
Yeah. Okay,
so this is z, but critical, in this case at 10%, and this is test statistic.
Yeah. Okay, I got that. I just want, so the stuff we did today, it's a little more challenging than what we did on Wednesday. It's like right now you're comparing two sample means, and last class we were just working with one.
The logic is the same. So just go over it, and then if you have more, you will find it out that it's like very similar. The logic is the same. You simply need to understand the idea of it, and then you'll be fine.
All right.
Entirely based on this logic.
Okay.
If you guys have any questions, let me know. That's why I'm here.
Professor.
Sure.
I have a question about when we were calculating the difference in mean scores for New Jersey and Iowa.
Right.
So it was similar to a homework problem that I did, but
yeah,
the way how you did it was slightly different. But because you subtracted Iowa and then New Jersey, but on the homework I did New Jersey from Iowa, but it's the same thing, but
the same thing because you are interested whether there is a difference.
Yeah,
in statistical sense, right? Yeah, so it doesn't really matter if it is like if there is a difference, one always will be higher than the other, right? So it doesn't really matter. You are not checking which one is higher. You are checking whether there is a difference in statistical sense. Are you with me?
So it wouldn't matter if I do y1 minus y2 or y2 minus y1, right?
Entirely not. Definitely not.
Okay, because that was just what I was curious about, because when I tried the class problem, I got different numbers, so that's why. But
no, you should get the same number with a different sign. The number will be different because you got different numbers in your problems.
Okay.
But subtracting Iowa from New Jersey or New Jersey from Iowa will yield the same numbers, results, but the signs will be different. One will be plus, one will be minus.
Okay, thank you.
Okay. Okay, guys, then let me leave, and I wish you a good day. And do you have any questions?
Nope. Professor, I'm going to email you about the midterm date.
Yes, please email me if you find this date inconvenient. Then please explain why, and then I will reschedule it for you. Okay, guys, have a nice day, and see you on Wednesday.